I'm live. Hello, people watching the stream. Hello, people in the room. I am Scott Garner for the 7,000th time. You've all heard this a billion times, but I make interactive things with technology usually, and it varies quite a bit. Guess that's enough intro. So now we can go to this slide. It's very short. I realized after I said it, like, oh, I've already introduced myself so many times that everybody's probably sick of me. But we're going to look at some work a little more. And what we're going to talk about today, specifically today, kind of in contrast to some of the other talks we've had, is specifically about interactive projections. So like large digital projections that have some interactivity. And I just gave a little bulleted list to sort of narrow that down to make it distinct from some of the other sort of like interactive murals we've had or other kinds of screen-based experiences that we have, because there are some different considerations, even though a lot of the tools overlap and the techniques overlap. But yeah, we're saying we have some digital interactive experience. It's produced for screens. In this case, it's a deliberately large format display of that work, and then there's a layer of interactivity. And that's kind of like, you know, the bounds of what we're going to talk about today, and we'll kind of dive into how this manifests, because it actually, you know, even though it's sort of a corner of the world of interactivity, especially in recent years, it has kind of ballooned into some very large scale experiences. And so we'll talk a little bit like how we got to the large scale experiences. We'll talk about some of the tools and techniques, talk about how to kind of manage some of those things, and how to make them sort of interesting, engaging, interactive experiences for the people that are standing in front of them, because the considerations really are different for something that is, you know, handheld or small scale or screen space or things like that. The rules are a little. So I thought I would start with a little history. It's one of those things that's strange for a very, like, especially in this case, like a very kind of new medium or a new corner of an existing medium. And so this is by no means exhaustive. This is just sort of my own mental map of the pieces that I've seen that I think specifically fall into this realm of the interactive projections. And so I'm sure somebody can find, you know, you never can say that something's the first, because someone will dig up and be like, well, actually, 1 year before someone did this in Amsterdam. So I'm not going to make any claim that Points of View is the first interactive projection. It's the first one I know about. And it kind of shows this step away from, or not away, just like a step in a new direction relative to a lot of sort of the video art that was happening in the 70s and early 80s, where this one it's not a passive piece of content. And so I wanted to look at it a little bit, because it's pretty interesting, and I think it's interesting to see kind of where it started and then where we've kind of ended up. And so this is, it's an artwork by an artist named Jeffrey Shaw. I believe there's some other credits up there in the corner on the people who did kind of some of the technology and hardware layer. The thing that I think is really interesting about this is you can see just looking at it that it's still so steeped in the world of like, well, you know, you like sit in front of a TV and things happen, or you sit in front of a movie screen and things happen, right? Like it took us a while to get to the idea that like, oh, you can stand up and play around and so on. So even though I would consider this one of the first interactive projections, it's really for one person to control. The interactivity is limited to one human who's going to sit in that chair there. There's this large screen that it is a projection, but you can even see the feel of it, the curvature of it, sort of the format of it is kind of what we would think of now as like a large screen TV or something like that. It did have a pretty heavy audio component, and you can kind of see up on the screen, it's pretty abstract. I mean, in this image certainly, but it was just pretty abstract in terms of the work. So here's a little bit of layout of the hardware, and you can see we have a user here, we have a projection, and the controls were actually kind of mounted with the seat. And so one person at a time would sit there and they would kind of control this experience. And so then the question is kind of, well, what was the experience? So it was kind of in the realm of almost, I think, technology-wise, and I think it's mentioned in this description, but of early sort of like flight simulator software, of sort of like very kind of primitive shapes represented in wireframe. I think this is a kind of a view that shows you this sort of theatrical playing field with these glyphs that are, I think, either inspired by or even drawn directly from the Egyptian alphabet, from kind of these like very pictographic figures that are on this sort of stage. It was kind of a theatrical experience, and the main agency that you had as a viewer or participant here, and you can see, you know, there's just lots of people standing around, but very often there's really one person in charge. And the idea was sort of that this person, so you see this person sitting here, there's a hand on a little slider and a hand on the joystick. This person becomes essentially the director of this experience that's playing out, this primitive wireframe. When I say primitive, I mean that in terms of like primitive geometry, not in terms of rudimentary, although it's fairly rudimentary by today's standards. And that's kind of where we started. And just to think, the notion of that, especially in this era, I mean, there's certainly, you know, we're already into the era of video games. We're a few years past Pac-Man, Donkey Kong, things like that. So people are pretty used to going into an arcade, having a screen, having joysticks and controls. You can certainly see some of that influence here as well. But this one was, the intention was a bit more of kind of an art experience, a theatrical experience that you're controlling it. They made these cool kind of custom controllers, which is another thing we kind of take for granted now, like how do you interact with a 3D scene? What's the appropriate way to interact with that? So there's some custom hardware associated with this. And so I just want to show this as the kind of starting point. Again, I'm sure we can find a million other, I'm sure there's examples that predate this that you could argue are interactive projections, but I like this one because I think it touches on a fair number of things that you know, some of these things work, and they still work. Some of these things didn't work quite as well and have sort of evolved since then. But as far as a digital experience, kind of a digitally created art experience, in this case, I think with some like early, I mentioned with it's on an Apple IIe, low resolution, low frame rate. You can actually see a video that shows I'm interested just to kind of show you what so you can kind of see the frame rate, not the quickest, not the fastest to navigate. Again, very much sort of a individual person, one at a time with people standing around. But I like it. I actually like it quite a lot. I think that it sets a foundation that will look a little bit how that evolves over time. And so work like this continued, and in particular, obviously, in arcades, that kind of like you sit and you have controls and control an image on a screen was definitely a thing, especially sort of the individual user version of that. Anybody who's has a fondness for video games, it's not hard to look back and see, especially the 80s and early 90s as sort of this kind of renaissance of interactivity on screens for you to pump quarters into, and you can just watch how rapidly the graphics evolved. But the next one I want to point out, we're going to fast forward in time a little bit because some new technologies or new techniques became available, especially sort of mid to late 90s. And so I wanted to point out texturing because this one I think is also another, especially just in the world of art, like this is, I believe this is the Smithsonian American Art Museum. Like this is considered among the history of digital interactive artwork. I would say texturing is a pretty pivotal piece for that. And again, it's something that maybe by today's standards may look or seem simple, but I will say there's a copy of this at the Children's Museum of Pittsburgh where I spend a lot of time, and it continues to be one of the most popular exhibits even today, even over 20 years later, even with the sort of simplicity of the execution of it. And so to describe that execution, as you can kind of see here, it is what I would consider now sort of a form of digital mirror. So you as the user are standing in front of a wall. Usually, I think the way it's installed varies. The way I have seen it installed is very often on this wall where the projection is happening. There's usually a pinhole, like a pinhole. And then the letters of the poem fall from the ceiling, from the top of the screen, and then they sort of gather on your body. And this was kind of a big deal at the time, especially just as an artwork, because even just the processing that we would take for granted now for computer vision tasks like this was, the processing power is very limited, and the sort of tools and techniques that we have to do something now that we might take for granted with something like machine learning, of recognizing the form of a human body, had to be done a bit more brute force at this time. And it was much more a process, and we'll talk a bit more about this, of generally of like pixel analysis, looking for hard contrasty edges, things like that. And so it was, and to add to that, many of the tools that we have now that make programming more accessible, things like processing or Unity or all of these things that you may have heard the term of like, oh, these tools have been democratized, which is a weird way to say it, but just that the availability of the tools, this kind of predates that era, but even by a few years of even processing. And so I think one of the things that, again, is really impressive about this work is not only as an example of this early projected interactive artwork, the layer of interaction is just your own body, which we'll talk about a little more as something that humans are very in tune with, but also just as a very early point of computer vision, which 10 years after this suddenly is the introduction of the Kinect, and then that becomes very popular. But I think this is a good one to have on your radar, just again as like a little point along the history as we move along here. So the next one I wanted to talk about is Funky Forest. We talked a little bit about Design.io, I think during maybe the introduction to this set of streams, or maybe the last set of streams. It is, I always get their name wrong, Emily Gobelay, I believe is the correct pronunciation, and Theo Watson. They're always like introducing themselves as just Emily and Theo when they give talks, and so it's a last name I have not heard often enough. But they have a kind of design art studio called Design.io, and I believe we looked at some of the pieces that they've done just as a quick overview of some of the introductions here. So this, and to be clear, we've now flash forwarded even further. Now we're in 2007. Something that is different now is now we kind of are getting into the era of the tools being a little more available, of the hardware being more performant, that you can start to do more ambitious things, especially with just a small team of 2 artists in this case. So I'm going to mute this and just play a little bit of this while I talk, because you can see a lot of different kinds of interaction here that are working in kind of a lot of different ways, but principally with computer vision. And very often, but still kind of, by today's standards, a bit more of the kind of earlier sort of brute force versions of computer vision. So, for example, the water blocking there, in this era, you would usually do that with some kind of blob detection. And so maybe you'd have an infrared camera shining down, you'd look for something blobby, like a black blob, and then you would say like, okay, I'm gonna use that as a barrier for the particles. So that was, especially at the time, like that was just such an incredible thing to like project on the floor. You can see the kids love it. Kind of the ability to manipulate these particle systems. There's also this beautiful forest on the wall that shows, I believe these fireflies will kind of track to you if you get near them, but the more impressive part, and I think this is a thing that has shown up in the Design.io's work repeatedly, is this, again, it's a form of mirror, but as the kiddos here you see are standing in front of the projection and kind of holding their arms up, they are recognized as being in a tree-ish pose. Again, sort of like, maybe by today's standards, a more simplified form of computer vision, but you can see these kiddos standing in front, and then they have trees sort of growing in response right in front of them. And so I still consider this to be in the tradition of something like TextStrain, because there's just something very inviting and very just resonant for people to see their own bodies either directly shown back to them. And I think some of you took Yuri's workshop a few weeks ago with the GLSL shaders and seeing just what you can do with sort of interactive digital mirrors. So there's that level where you're seeing yourself literally, but also in forms like this that are a little more abstract, where you can see kind of a response to what you're doing. And speaking of the tools that were used here, I believe this was primarily open frameworks. And Theo Watson at the time, I'm actually honestly not sure if they've moved on or if that's still the tool set they use. It was definitely a period where open frameworks was quite popular, but I would put it in or becoming popular, I should say. And this is even a little bit earlier, so this is probably predating that a little bit, but it's something that as we go into the 2010s, we started having what people would call like creative code frameworks, things like open frameworks, things like Cinder, which I'm honestly not sure if people use very much anymore, things like processing was frequently used for installations like this. I think there's definitely people still using open frameworks. It's still popular. It is kind of designed as a C++ toolkit for interactive experiences, especially interactive projections, installations, things like this. I've lost a thread on it a little bit, honestly, just because in the latter half of the 2010s, there were suddenly so many new tools, and many of them quite robust. And tools specifically geared towards this realm, tools like Touch Designer, which I think Justin talked about on Saturday. And so, but I do feel like one of the main things I wanted to point out to this one, because again, I'm sure someone could name an earlier point, but this is one of the points that I really remember as like, okay, we're not just talking about, you know, we started with that first point of view. It was still a screen. It was a big screen, but it was still basically a screen. Then we moved on to text strain, and it was suddenly like, oh, there's a wall. So we have a full wall interaction. By the time we get here, by the time we get to Funky Forest, Design.io is kind of like, okay, what if the whole room was interactive? What if the floors are interactive, the walls are interactive? And obviously, there's challenges there, right? It's got to be a multi-projection setup. There have to be multiple cameras. You can see that things like shadows become a real challenge, because if you're standing right in front of a projection, you're being projected on. And at this time, some of those, you know, maybe those problems they weren't super concerned with, or they just kind of worked around them. But yeah, this was moving more into like, okay, we're making a space here. It's relatively small scale. They've gotten much bigger scale over time. But I think the people that sort of took over as sort of the huge scale, and now we're going to flash forward to 2013, the sort of like ultra huge scale installations is TeamLab, and they continue to be that kind of thing. I have weird biases because I just like Design.io, and I like they're a little more sort of like, you know, art team, whereas now TeamLab has gotten so huge and is often quite commercial. It's just, they've done beautiful things, and I don't want to sort of discredit the work in that way, but I guess the scope and scale and budgets of their projects, we're now like probably into the millions, multi-millions of dollars. So I think it's important to remember like some of the things like text strain, it's like, okay, that's in the realm of like, you could do that, a small team of people could do that, something like that. Once you start to get into TeamLab, many of their installations, which are often like permanent installations at cultural institutions, things like that, beautiful installations, but they really are of a scale that is now we're kind of in a very commercial scale. And I think that's something that happened in the 2010s, where about 10 years ago, suddenly there was this idea of a job called creative technologist. Lots of advertising agencies, studios that maybe traditionally specialized in advertising for television or even in website design, suddenly were like, okay, now we're going to be interactive. Or those kinds of people decided to have interactive agencies, interactive studios. And so there's, I don't know, part of me is bummed out a little bit by it just because of the intense level of commercialization of this kind of work, where that is the scale, I guess, that kind of dominates the conversation to some extent, and you don't see as much, it still exists of course, but you don't see as much, I feel, these sort of like smaller scale, smaller teams, individual artworks of these kinds of things. But just recognize it is a huge kind of spectrum of complexity and team size and cost. This is my favorite work of theirs. They have many beautiful pieces. I think we did show a work as part of the intro. This is my favorite because the level of interaction in this is something I would call a little bit more like asynchronous interaction. I think there is some degree of real time, but it's less about something like Funky Forest where you're standing there, you're seeing something immediately. Or text strain, you're standing there, you're seeing your own body immediately. The idea here is that kiddos visit, this is an aquarium, I believe it's in Tokyo. The kiddos visit, they're able to sort of take these preset templates and kind of color in the lines, make their own designs, and then they have this capture process, which to me, I don't know, again, I'm gonna try to not be too biased about it. I feel like this is not a very magical process. You have this magical, but you have a magical moment that once it's scanned, you see your fish, your drawing, not only appear on the screen, but like swim and animate and move through the environment and kind of come to life. And so it's, I mean, you can just see the kids, like what a magical time it is because they see their own little creations come to life here. But I guess one distinction I do want to point out here is like, okay, this is a little different, and I may be mistaken, but I do believe there was also some computer vision of like the aquatic life responding to humans. I may be mistaken on that, but definitely there was the idea of you create your artwork and then you see your artwork there. As you leave, you know, you might leave the room, but your little fish or your little turtle can still swim around. And so I think that's something I like in interactivity anyway. You know, the ability for there to be an artwork that persists over time, that individual people, the art is created by the people that visit it and interact with it over time. And I think there's something really special about that. And I think this is one of my favorite examples of that. And again, it's a case that you can see, and if we just look at the TeamLab site, I mean, as far as that idea of like transforming a space into a fully digital environment, they really are kind of second to none at that kind of very large, that large scale. And I think one thing I would add to this, just one more comment and we'll move along, is I think for myself and I think for some other people at SETI, there's kind of a question of where does this fit into the realm of things like AR and VR or XR more broadly? And I think I'm of the opinion, and I would kind of generally agree with other people here at SETI in the discussion, that this kind of projected environment, whether it's like this architectural projection or more like a projected deliberately projection mapped, which I think we've seen some of over the workshops, over the course of the institutes and the workshops, does qualify for that. And to me, with where we are in terms of the technology, it can be a bit more magical because there's no device. You're not like tied to a device. You don't need a headset on your head. You don't need to be staring through your phone. You're able to just be in a space. And I think there's something really special and magical about that. There are aspects of it, of course, that make it a little bit of a challenge. Like, as you can see, these people are casting shadows. It can take a whole lot of projectors to cover a space. It can take very complex software. But I just want to show you kind of the high end of the possibilities with these kinds of installs. And here you can see some projection mapping, some physical elements in the space that can be really striking, really, really, really beautiful. Here you can see that this is kind of another topic of incorporating physical objects to make kind of that hybrid physical digital experience, which is one of my favorite things to do. But yeah, so that's our like little snapshot through history, just so you can sort of see. And I think it's very striking to me, maybe it will be striking to you, how quickly we went from this as sort of the state of the art of an interactive projected art experience. So again, this is early 80s, and so from there, 30 years later, kind of going through these other steps, now we're just at these like totally immersive, these environments that just fully surround you in these visuals, and not just surround you, but allow you some agency to interact and play and participate. So, given that, hopefully that like gets your gears turning a little bit on ideas, things you want to do, things that are possible there. I thought for today, what might be helpful is, especially for people that are new to the idea and just want to, learn a little bit, like, what are some techniques? How can you do this? Like, how can you create some interactivity in this space? So I've listed a few categories, and we're going to kind of dive in and talk about these ideas of like, okay, I get it. I'm going to have some sort of digital content. I'm going to put that digital content on a wall or a building or surround a whole room. But then you have the question of, how do I let humans interact with that? Like, how does a human have agency to play and respond? Because again, it can be beautiful to be in a space and just look around and see that space as beautiful, but there's something else and something special. And I would even recommend, if you didn't catch it, Ben's talk last week on the difference that agency can make in a story. And I think that's true for environmental storytelling as well, is that it's beautiful to have a story told to you. If you feel like you have a stake in that story or a participant in that story, or have especially some agency to like leave a piece of you as part of it, I think it can be really incredible. So this is by no means, some exhaustive textbook list. This is just out of my brain and out of the work that I do and the work that I've seen. I'm sure we could think of other examples of this, but I want to run through these and we're going to kind of dive into them because there's challenges and benefits to all of these. I've seen sometimes these things mixed and matched, but we're going to kind of treat them as like isolated ideas and just dive into them a little bit. And so the first one is computer vision. And if you're not familiar with that topic, it's a pretty big topic, and it is a topic that has dramatically changed in the last 10 years. But we'll dive into it. The general idea is that you have a camera of some kind that is looking at the space, looking at the people, and the computer itself is going to analyze that image, and there will be some result from that. So for example, with TextTrain, going back to TextTrain, there was the idea of, okay, my body is like this, the camera will see me and put the text on my body. So that's an example of again, sort of not fully rudimentary, but a simpler form of computer vision versus what we may have today of like very complex AI-driven, not just detecting my body, detecting the pose of my body, making assumptions about where my skeleton is, segmenting my body so that I can tell my hands from my feet, things like that. It's a big topic. We'll get into it a little bit today. There's also the physical computing aspect of it. Physical computing, again, being if you took that workshop that I did on sensing the world and talking about the sensors, all the stuff that we did with microcontrollers in the microcontroller workshop and the kind of circuit playground that we played with. I think a thing that is cool to recognize is that this world of physical computing, physical hardware, can tie into these projections. And that's my personal, for me and the work that I do, I'm not as big a fan as computer vision. I like the more like physical interaction with things, but just to know that that's another track. And again, they're not mutually exclusive. Moving even further is the idea of real-time networking, and this is a thing that I'm a little on the fence about, honestly, but I've been moving towards a bit more, only because everybody has a phone. That's not true. Most people have a phone that you would potentially be catering to in these spaces, and if they don't, you can certainly have devices available, iPads, phones. It's possible to make an experience where people have the ability to see it through a phone or device. And I think an important thing to remember about this little machine is it also has a bunch of sensors on it as well. So just the exact same way that that circuit playground has an embarrassment of sensors built right in, this thing has an embarrassment of sensors built right in. Obviously, it has a microphone to talk into. Obviously, it has a camera to look at the world. It has a touch screen. It has things like a gyroscope to tell if you're tilting in space. And so it's possible to say like, well, I'm gonna have a big physical projection, and especially if you have a room with a whole lot of people, that would be hard to let them physically interact or stand directly in front. Imagine you have a whole audience even. Phones can be a really interesting way to get information from that people, participation from that people into some larger system. So we'll look at that a little bit. And again, the idea of this is real time. So I'm touching my phone, seeing things happening on the projection. And then finally is something I alluded to with the team lab. I probably should group these together, but I think they have a different feel and are maybe more appropriate in different kinds of contexts, is this async networking, meaning the people participate by creating something or tweeting or posting a photo. That information goes somewhere and is kind of stored and then becomes part of the projection. So I think the team lab with the fish, hopefully that distinction's clear from like the real-time interaction or like I'm gonna leave something. And again, none of these are mutually exclusive at all. There's lots of kind of blurriness between those. And it is possible to kind of mix and match them if you want. So, computer vision is a pretty big topic, and it's, as I said, it's a topic that has changed pretty dramatically, I would say, in the last 5-6 years from what it was for a few decades before that. But just to call out a few concepts here, and for those of you that took Yuri's workshop, you'll remember that you just use the webcam on your computer. So you can start with just a webcam type camera, but there are also any number of more specialized, more complex cameras. And that includes things like, if you've heard of the Kinect or the Intel RealSense cameras, various kinds of stereo cameras, meaning that instead of one lens, there's kind of two lenses that are known at a distance. IR, as I mentioned early on, was very popular in interactive installations for a couple reasons, but it's infrared, it's part of the the spectrum of light that we can't see, so it can be very convenient if you want to keep your space dark, but still know where people are. You can light up the whole space with IR. Humans won't see it, but the computer can. And so that can be very useful. For example, that kind of blob detection, if you have a person standing in front of a projection and you just have a regular camera, it's hard to tell where the human starts and the projection stops. And so specialized cameras can help with that. So there's the hardware part of it, I guess I would say. Some kind of camera that is going to take some kind of image. And that image might be really complicated. It might not be an image, that works in the same way that humans think of these images, especially for things like LiDAR cameras that are actually more like little radars, but without radiation. It's light. They're bouncing light off things. Then there's usually some layer of software that, and that's not entirely true now because there now is more specialized AI computer vision hardware, but broadly I would say the computer is going to do some work. It's often a software solution, or at least has a software layer. And then I think the thing I really want to point out is the range of what you can do in computer vision. It's such a huge topic. It is used in so many things. It's used in security, it's used in privacy, it's used in manufacturing. It is a realm. It's used in surveillance. It's used in some countries to violate the privacy of their citizens by tracking their faces every step they take. So it is a pretty advanced corner of computing. And as I said, it's kind of changed a lot. So those earlier examples, and we could even just look at a Schiffman video. So if we were Schiffman blob detection, for example, very simple versions of this kind of computing. So okay, here's Dan. He's having a great time. He's got a red cup, and you can see he has a circle on his red cup, right? He just has a red cup taped to the wall. Everybody should watch Schiffman videos if you want to know anything about getting started in programming or interactivity. He's the person to go to. But the thing I want to point out is in this realm, it's kind of brute force, meaning the way he's written his code, he just goes through, he gets the image from the camera, he's going to go through every pixel in that image and just look for parts of the image that appear to be red. And it really is as kind of when you say it kind of clunky and brute force as it sounds, it is a very, it's kind of the way you'd think of it as a human, a sort of intuitive sort of human idea of okay. And if you're interested, you should check out his videos, and he'll walk through and kind of talk about how do you decide if a pixel is red, and how do you draw something there. But so there he's doing green, so he changes it to green and it does the background. But this idea of color detection or blob detection is just a form of pixel processing. You get an image, then you look at the image, and I mean that in the abstract. The computer, you're going to look at every pixel. You're going to say this part of the image is really bright, this part of the image is really red, and so on. And that was kind of the way things were done for quite a stretch, since I would maybe say in the 90s, possibly 80s, of when computer vision became kind of a concept, up until recent years, where we've now moved much more into AI-driven models of how to do that. And so the distinction would be, for example, if I wanted to know where my hand was, and I was going to do it in that old school way, it would be all right, it's going to be a little annoying, but I'm going to loop through the pixels and kind of, maybe if my hand's against a dark background, I can look for some color differences. Maybe I can figure out something weird where it's okay, I'm going to kind of look for angles or some orientation thing. That's often not how it is now. Now it might be more something okay, I'm going to make a data model where I take 12,000 pictures of people's hands, and then I'm going to train the computer basically just to know what a hand looks like, and then I will use that AI model. So does that distinction make sense? Because it's a pretty huge departure in my mind between the way computer vision used to work, which was very often about pixel analysis and processing and making guesses by just analyzing the pixels, and this sort of new realm, which is in the same family tree, but is kind of conceptually very different, where it's if I want to detect a dog, I'm going to make an AI, some ML system where I'm going to train it on 1,000, 10,000, 100,000 pictures of a dog. So that's changed quite a bit. Even when the Kinect came out, I mentioned skeletal tracking here. So we talked about with TextRain, how people like mirrors, they like to see their bodies. Something that became popular with the release of the Kinect around 2010, I guess a little earlier than that maybe, was the idea that you could stand there, and it was an annoying process, so you would go stand kind of like this, and it would take a moment, and then the software would detect you, and then it could tell where your body was. And it didn't work super well. It didn't work very well in my experience in art installations, even though people love Kinects. It never worked super well in like Microsoft, their main release for it was for gaming, like playing video games at home. None of those games were very great, in my opinion. And Microsoft kind of eventually gave up on it. Like as a consumer device, they just eventually were like, we're not gonna do that anymore. They still have that work and that hardware and that technology, but it's a bit more in like again, in those realms I was mentioning, like privacy, security, manufacturing, things like that. It's a little bit less about sort of home entertainment. But the way that it was done at that time versus the way it's done now has also changed quite a lot. Where to now again, it might be like, rather than me trying to write some really complicated thing that's going to look at an image and kind of look at all the details and decide if that's a human, it could be more like, we just have a huge body of work, of photographs of people in every pose, and we're able to reference those. And so, for example, one that's popular now, I think is Posenet. There's a few of them. But you can do things like this. Given an image, just an image of a human like that, you can start to make assumptions about where that person's skeleton is. And it's a simplified skeleton. We're not worried about hundreds of bones. We're usually worried about just a few major joints like wrist, elbow, things like that. But this is kind of enough for fun interactions, to like know if you know where someone's wrist is or their hands are, you can start reacting to that. If you know where their face is, their eyes, nose, mouth, you can put masks on them, things like that. And so it is a huge realm that, again, can start very simple. If you just go watch those Dan Schiffman videos, you can track an orange ping pong ball, or it can get much more complex with skeletal tracking, which in my mind, so much of this has moved to these sort of ML-driven models. And in fact, the biggest indicator I would say is Opencv, in my mind, has just been it's kind of an open computer vision library that's been around for a few decades. And it has, as long as I've been doing this kind of work, Opencv has been sort of like, if you're doing anything with computer vision, you should use Opencv, just because it has all of these things built in, like blob detection, things like that. Somebody already wrote it and you could use it. The thing that really has changed, and almost to a surprising extent, is they're just kind of all in now on the ML-driven models, just because they are so, there's so many more possibilities if you can just train a computer what hands look like, or humans look like, or faces look like, rather than this kind of more brute force method. We still use those brute force methods for sure in a lot of cases, but the world just almost like dizzyingly for me has very quickly moved towards these AI models. In fact, they have some cameras now that they sell. They're called Oak cameras, Oak D cameras, that are cameras almost like these cameras, like a webcam, but they have some of this machine learning. They're kind of purpose built for machine learning. And if you remember the Microsoft Kinect, they now have the Azure Kinect DK, which seems still to be very difficult to get, which is also more based on running ML models on the images you're looking at, just because kind of that industry has decided this is the way to do it. And I'm sure from someone who does this every day, it's been a slow move, but for me, it was a very fast change to kind of see how quickly computer vision became tied into machine learning. And so I'm going to pick kind of a little bit older example of one of, to me, where we got, this was kind of that first step in my mind of going from, we saw TextRain, which was just sort of, it could detect an outline of the human body. So going back to TextRain, very early, 1999, it can kind of figure out where your outline is just because the pixels are a little darker and drop text there, right? This Treachery of Sanctuary by Chris Melk, well, you'll see, it was a pretty dramatic change. So this is made with Unity, I believe, and I believe it was a Kinect because that was kind of at the time how to do this. But if you watch this video, let's do it. Is there audio? How do I make there not be audio? I don't want audio. Can I really not choose to not have audio? That's a little silly. Okay, well, I guess we're stuck with audio. But so it begins with that kind of idea like, I'm standing there and there's my silhouette. and then it very quickly changes in terms of the way it responds to your body to be something sort of much like beyond that. And so Chris Milk now is with, I think, Supernatural, the kind of VR exercise company. So there's a little mini documentary on this. I just want to find video to show you what it's like. Maybe not. Okay, so you can see these are people moving. There were 3 stations, I believe, but the one on the far left is the one that was really incredible to me, where it had the layer of just the computer vision of it's going to track. There's a human standing there. Actually, all 3 of these do that. It recognizes sort of your silhouette as the silhouette of a person, and then is able to add this whole other layer of art and interactivity on it. And again, this was done with the Kinect, I believe, but the one on the far left is the one that is the most passionate. If you would just show it for 1 second. Okay, that one was pretty incredible, because you would approach it, you would stand there, it really just kind of looked like a mirror. You saw your body, and then suddenly these wings would sort of emerge out and fold out. And this is 10 years ago. Again, this is one of those things that by today's standards is maybe not as impressive, but this to me, I'm not a big fan of Kinect personally, and I've rarely found it to work kind of as advertised, but I think this was one of the examples of like, okay, I think they actually really did something interesting and beautiful with this sort of pose and skeletal tracking. So as in the realm of computer vision, as huge as it is, this one is really sticks out in my memory as a moment of like, okay, like they were really able to create something pretty stunning. Just how elegant that is, how smooth and how beautifully it folds out. Like I think they did a pretty incredible job. And I might be mistaken. I do think that was done in Unity. With them, yeah. So okay, so yes, it was actually both. So the Open Frameworks, which is what I mentioned as that kind of C++ creative coding, a little lower level, that was talking to the Kinect, and then the actual sort of visual drawing part was done with Unity. Unity of 10 years ago too, which was much more limited. But I think that's actually a major thing to point out, and is very common with projects of this scope and scale, is that it's pretty rare that it's one thing, or that it's one technology, one piece of software. It is very often, for those of you that have done any kind of like performance production or things like that, you know, there's like, okay, there's the audio system and it's its whole thing, and there's the lighting system, and there's all these pieces that you usually have, you know, well-trained technicians just on these parts trying to run it. That often becomes true in these cases, where you have, you know, just, I didn't work on this project at all, but just looking at it, I mean, it's easy to think like, okay, there's the big stage and lighting, the physical staging of the space, which is its own set of skills. There's the computer vision part of it, that's its own set of skills. There's the digital art part of it, which is its own set of skills. So not that this is out of reach for an individual person. I do believe this was a relatively small team, but it often becomes a combination of a lot of ingredients that go together. And then the thing that I find is that what becomes special because of it, or where the special aspect emerges, is how you as the artist put the ingredients together. And very often it's sort of like, well, no one's kind of put this together and this together and this together. And I think even this one, the documentary, it's been a long time since I watched it. It's an interesting watch here. So again, it's linked in this document. I should have mentioned this at the top. So at workshops.j38.net, as always, I'm sure you've heard it 100 times, but I do have all my notes there if you want to click through. But the Treachery of Sanctuary, and to me it was really striking because in this tradition of shadow art, there's centuries and centuries of tradition of telling stories through shadow or cut paper or puppetry or performance that just goes back hundreds and hundreds of years. Many, many cultures have forms of that kind of shadow art performance. So I was really interested in that aspect of it, of taking this in some ways very traditional art form of like telling stories through shadows on a wall or shadows on a screen, or like magic lantern shows, that kind of thing, and bringing that into a more modern context with this new technology. I would say, you know, I mentioned that earlier, that era, that transition into the era of like creative technologist becoming a word. Chris Melk was definitely on the forefront of that with Aaron Koblin, who also worked as part of the Google Data Arts team. They did a lot of incredible work of interactive especially like net art. You probably have seen some of their work before. It's a little weird to me now that they have like this VR fitness company, but they do have very, the environments in their VR fitness company are quite lovely. Okay, so that's the computer vision era. And I will, if anybody's interested in that realm, I can try to, I can speak to it to some degree, but again, it's not my favorite. It's relatively rare for me to work with cameras. I definitely have kind of a bias against a Kinect just because I've always found it to be very finicky and to never work as well as promised. Some of these newer versions, these newer systems, especially tools for skeletal tracking, I think have improved where it's now to the point it's like, okay, maybe I would do a project like that. So as an example, IBM had for the Apollo mission recently, let's see. Just got to remember which studio did the work on it. Okay, so there was this large-scale installation that IBM created to kind of commemorate the Apollo moon landing. And so there were astronauts projected on this large screen. There was also kind of this illuminated floor that kind of puts you on the surface of the moon. And astronauts on screen, relatively high fidelity 3D models, rigged characters. I think David talked a little bit about rigging last week. It's sort of when we talk about animated characters on a screen, rigging means you put some bones into them. So you can kind of move them a bit more like a human would move often. It's very common in 3D animation, actually becoming quite common in 2D animation as well. This particular system, I think, used a networked solution called Wrench. And I believe, I might be mistaken on this, I think it was Intel RealSense cameras, but it was not a Kinect, it was another kind of camera. But the processing of the image is actually where all the work happened. And so people could stand in front of here, they could move and dance and play, and they would have astronauts mirror their actions on the surface of the moon using this computer vision software, which I believe this case was Wrench AI. This was a pretty large scale. I'm sure it was very expensive. It has all the fancy making of videos if you want to dive into it. I believe they used Unreal, the video game engine Unreal, for the graphics. And I believe, I don't even remember why, actually, but another example of there being lots of pieces, they used Touch Designer for something. I don't exactly know where that came in. Maybe it was for compositing images for Unreal. I believe the real-time graphics part was Unreal, and then the computer vision part of it, I believe, was a tool called Wrench. And so it's been such a big change, I think, and that is something that, again, as in recent years has changed a lot, is as of a few years ago, if you wanted to do these like more complicated mirror kinds of things where you can really know where a human's body is and those sorts of things, that has changed so much to where rather than saying you need a very specialized camera like a Kinect or a RealSense or those sorts of things, that the computer vision or software in the machine learning models are so good now that you can often get away with just a regular camera if you've got the right software setup. And so there's these very complicated software setups. However, just ARKit from Apple, Apple's augmented reality toolkit, does have some pose detection as well. Google has some version of it too. As I mentioned, there's Posenet. So there's lots of ways to do that now in a way that you don't necessarily need like the specialized hardware that you needed even as a few years ago. That said, those Oak-D cameras are kind of cool and we have a few. So that's computer vision. Again, not my favorite realm, but there's just no question that people like to see scenes react to their body. Like it's a very human thing. Even if you just put you've seen like funhouse mirrors and things like that. You don't even have to have a computer vision part. If you just put a weird mirror up, people will move in front of it. Like people just, it's some fundamental sort of very human narcissism that we have. So that is that realm. Then there's the realm of physical computing. And I won't go super deep into this at the moment, other than to say there's often a microcontroller, Arduino, TNT, whatever. My talk from a few weeks ago, for anybody watching at home or anybody that didn't catch it, I did that talk both on Sensing the World, which should be on the YouTube channel, and kind of an intro into microcontrollers on using things like Arduinos, Teensies. We talked a lot about the Circuit Playground Express, which we'll talk about a bit more today. In my mind, the two big challenges here, obviously the concept and the execution of the artwork is always a challenge, but two of the things that are complicated are, one, there's obviously a physical aspect to this. You're making physical devices, you're dealing with physical circuitry. There's all of that challenge. But one of the bigger challenges, and we'll talk about this today, and I have hopefully an easier solution for a little bit, is once you make this custom hardware, whatever it is, how do you make it talk to a computer? And there's a lot of ways to do that, and some of them are quite complicated, and some of them are a little simpler, so we'll talk about that. But I won't dwell on this a ton, other than I do want to show this work because it is again, I don't know, this probably doesn't really rate in terms of like the Hall of Fame or like some sort of, grand art, history of digital art, but it's something I like quite a lot because I think there's a creative layer of this that's really interesting. So I think this was like, mid-2010, so 2006 actually, mid-2000s. And the artist is Mary Flanagan, and her idea was to create, with the nostalgia that she had for the Atari as a video game platform from her childhood, to create a large-scale physical sculpture, very large scale, as you can see from the pictures, physical sculpture of a Atari controller, but then let you use it to play Atari games on a large-scale projection. And so I think there's a video here. The video is a little wild, not the most professional project documentation. There's a lot of examples of this. I happen to like this one a lot because I think just as an artistic device, the video, sorry, is not. Let's see, is there any better video footage? It's interesting to watch and kind of listen to her sort of talk about the inspiration. Let's see if we can find just a little bit better video. Oh, the video is just abysmal. Okay, well, you can at least see these kids like, full scale size playing with this joystick and have it respond. And so I think that's an interesting thing because one of the things that's a challenge, if we go back to that first piece that we looked at, a point of view piece, one of the problems with that piece was like, oh, well, that was a cool artwork, but only one person could use it at a time. And it was like the scale of the interaction was quite small, right? It was just this little, you just sit in a chair and you're basically just sitting in this wooden chair with these two controllers. And so I think one of the challenges of creating multi-user interactive artworks is often like, well, how do you engage a bunch of people in a space? A single wooden chair is maybe not the best way to do it. I mean, not that that's what this artist was going for, but it doesn't let everybody participate. And not that the Mary Flanagan's giant controller fully solves that problem, but I think it does solve the problem, or it presents an interesting solution to the problem. Actually, let's do this. Can I just do this? Okay, maybe that's a little better. Where if you just make something big enough and make it robust enough, which is definitely a challenge here. Like if you were gonna have kids touch anything, kids are like machines built to destroy things. And so if you're gonna make artwork that kids can interact with, very often the biggest challenge is just like, how do you make this where it can survive humans touching it? But I really like this one. I like it in terms of scale. I think it is an interesting project in terms of fabrication, which is something that really interests me. And for those of you that were in Sean's workshop last week with him talking about the materials and how do you fabricate these things, how do you put them together, this was a pretty major fabrication project to make something of this scale. Also, the custom electronics inside of this, because once you need to track something that big, the hardware you need to build your circuitry gets a little more challenging. I don't think she actually says what she uses. I think it's just, yes, a very art statement that it's wood, steel, paint, electronics. But I would assume, I don't actually know this, but my assumption would be that there was some kind of microcontroller inside. I think maybe there's an article that goes into that a little more deeply, but you could imagine certainly making this with something like an Arduino. It would not surprise me if there was an Arduino in here, or perhaps something a little more complex in terms of a microcontroller. But I think that's a fun way to have a physical object that lets a lot of people engage with something. It's purely just with working with scale. Moving on a little bit. So this one, I'm going to just talk about this one very briefly, but so I already showed that Team Lab example, and now I'll show you, it feels weird because everyone's seen my work a million times, but there is an idea here, and I think there's something to it, is that people can visit a projection and not necessarily interact in real time, but maybe see content left by other people, created by other people, and have the opportunity to create their own. So if you remember, we looked briefly at the Sketch Aquarium, and in terms of the Sketch Aquarium, it's a physical activity. Kids are on site, they are doing these drawings, and then it gets incorporated into that. That's a little bit different than what I'm talking to, although talking about here, the spirit is very similar. So I just listed an old project I did just because I didn't have a better example to mind. The idea here, it was actually for Web Visions here in Portland in like 2011, but the idea, I think it still works, let's see. I think the link doesn't work. But very simple, the idea was sort of to, with WebGL, make a very simple kind of 3D animated environment, and anybody who tweeted with the right hashtag, their tweet would end up here. And so this kind of content I found works well for something like, say there's a conference that's going on for a few days. So this was for Web Visions. I think it went on over the course of 3 or 4 days. This was a large scale projection that was just kind of off to the side in the main exhibit hall, but it was a way for people to tweet. And if they tweeted, Twitter was a very different thing at that time than it is now, but you could tweet a short tweet and then do hashtag, at the time, Web Visions. I think I have WebGL in as the default hashtag. But it was a way for people to interact, have like their message up, and people really, people were excited to see their message come up and go through, but it is asynchronous. And so there's no real-time reaction. There were a few things that were real-time, like over time, the time of day will change and it goes from night to day. So there were some sort of like slow things going, but the real idea was like, okay, you can have this kind of passive thing. It can be easy for people. It can be kind of off to the side, not taking a lot of room of people jumping and dancing and moving around, but people can interact with it easily. And for Web Visions in particular, they were really interested because it's made in WebGL, it uses web APIs, and it was a way to kind of encourage social media engagement, because then people are like, oh, I want to see my thing up there. Another example I have from a few years ago is, and actually maybe I like this other one a little more, even though it's slightly less realized, is the idea, and this is actually, I think, one of the more common ways to see this now, is, are you going to work? Can you do it? Kind of like interactive photo booths, things like that. So this was for a space called Lightbox, and it was a place that was sort of an event space that was billed for 360 projections. So they could project on all the walls. And so I built this tool for them to use for parties where you could take photos, and then it would, instead of having like a photo booth that would just print out your photo, it would take your photo and kind of put them large scale, larger than life on this huge cityscape. I had a few different ways to do it. I think this version actually was with Instagram. So you could take photos, post them to Instagram. Again, if you use like the right tag or whatever, it would show up. And then it was fun for people at the party to not just do the little photo booth and get the little screen, but like to do the photo booth and then see themselves on this huge projection. And so I think that's something that can be important. Again, this goes back to kind of that that Tokyo Aquarium one by Team Lab, is to, if people like to see themselves, they like to create something and see it up, they like to leave sort of their own mark on a piece. And so I think that interactive projections provide a way to do that not a ton of other content, or not a lot of other media will allow for. Like AR will certainly allow for that, but AR, you have to pick up your phone and you have to engage with it. This is a way to have a space dominated by artwork that is potentially, in this case, it was, the work that I did was mostly, well, how do I incorporate this artwork? It was a very simple model of a city, some very simple shaders to do the artwork, but so much of the question was like, okay, how do I give this sense of scale, like you're seeing yourself on Times Square or something like that for an event? The one thing that rubs me a little bit the wrong way of this kind of work in this realm is it became very much like a party favor kind of for corporate events. And so like huge corporate events corporate clients, things like that. They want their big party to have these kinds of things, and that's fine, and they often have big budgets for it, but I'm personally a little less, I do that work sometimes for sure, because they're like the patrons of our age, these huge companies, and so but it's not my favorite, because it's fun, and I like to see people have fun with the things that I make, but it is a little bit of a corporate party favor at a certain point. So that is kind of the async networking piece, that you can leave a piece. There's no rules for this. As you just saw, that was 2 examples of using social media APIs. So Twitter or Instagram. It could also be something that you built yourself. It could be some other tool. Basically, it just means people have the ability to put some content somewhere that your software can find later. And one of the things I do actually really like about it, and have seen used to great effect, is that this work can accumulate and build over time. And people, if you have something like, very often these are up for a very short period, like the duration of a festival or a conference, and they're up for just a few days. But I'm really interested in the possibility of like, there's no reason that these things couldn't accumulate for years, kind of other than the fact that it's just sort of a relatively new medium. And I can't really think of an example of that yet. It's in projection, at least. Aaron Koblin, who I mentioned, did things like the Johnny Cash project, where every frame of a Johnny Cash music video was drawn by an individual person. He's done a lot of stuff of that where it's like crowd share, like crowd people, which I really like. And another thing that I think is a bit different about this is you don't have to be there, which I think is interesting too. So you can this allows people to be there and interact, to be there and leave something, and then they're already gone, but their work still exists and persists for the new people. But it's also a way for remote people. So like that tweet example, for example, as other people were tweeting about web visions or whatever, even if they weren't there, they could become part of this projection. And because it was web-based, they could also just open it up in the web browser and see it. So, and then the last piece that I'm going to talk about in this realm, and then maybe we'll like get a little more hands-on, is the real-time networking. And that's something that I mentioned. I've been doing a fair amount of work in recent years of just using your phone as the way to do that. And it's certainly not the only way. David and I have also done lots of real-time multi-user networking thing with VR and with AR. We've done concerts where everybody at the concert had a VR headset on. I didn't include it here because it's not really a projection, but it was something that maybe traditionally would have been a projection. In fact, maybe I'll show it just because it's pretty silly. Kind of the stand-in for there being a large-scale projection is just, we had everybody in the audience, and this was some years ago where it was reasonable to just hand everybody a Google Cardboard. So this was for the Forbes, I forget which one, Forbes Under 30. So this was in Jerusalem. It was in a kind of some abandoned sort of ruins, but there was a band performing on stage. Traditionally, maybe you would imagine projecting some artwork behind the band, which is totally valid. You could imagine giving some interactivity for people to participate in that. Instead, we gave everybody Google Cardboards, which were popular at the time. So they were listening to the live music, but then they could put on this headset and they could sort of leave the shared physical space they were in and go to a shared virtual space and be there together. And we did a few projects in that realm of like live multi-user VR projects. Very often, we've also incorporated a projection part of that. So there's another one that we did. I'm not even sure if I have it documented here. It was also for Forbes, but there was a projection element in addition to that too. So these can also be kind of multimedia. So you could imagine, I have found those to be a little gimmicky, honestly, after trying it a few times, where it's like, oh, you can look at the projection, but there's also VR. I've definitely heard people think like, oh, maybe we have a projection, and then it's also AR. And my response is kind of like, why? Because you already have two, like, it doesn't feel necessary to me. Not that nobody will come up with a way to do that, but I have found personally that if you try to get like a little too, I don't know, ambitious and like, oh, we're gonna use this tech and this tech, and we're gonna do this and all of this, it just waters down the whole experience, and it means no piece of it is that good for anybody. And so I'm not as big a fan as the sort of add a bunch of tech for tech's sake. I much prefer to do that if there's some intention there. But often, especially kind of in this era, mid-2010s, it was very common to be like, Some client like Forbes would be like, we don't care what it is as long as no one's done it before, because we just want to do something no one's done before so we can put in our press release, we did this thing that nobody's done before. And honestly, that is a whole other side, but the one that I mentioned that was in Boston for Forbes actually didn't work very well in terms of the technology because of some networking issues, but they didn't care because the thing that was important to them was the like press release and the like little sizzle video and things like that. And I think that's another thing that kind of bummed me out. You know, as I was talking about these things becoming more corporate and more commercial, a thing that has happened a lot, in my opinion, is that these studios and agencies, they just want the video of the, you know, they want their 5-minute video to show like, we did this thing that no one's ever done before, and then that's what they care about. And so that's been a bit discouraging working in that realm, and it's been honestly a few years since I've even done anything in that realm because I find that a bit discouraging because the work almost becomes secondary. They're more focused on like the press release about the work, which is understandable. You know, like if you're like, okay, this physical space, maybe a few thousand people will see it, but if this YouTube video goes viral, maybe 10 million people will see it. So another topic, but on the realm of that real-time networking, I thought I would go into and talk a little bit about HelloSeti. Just was a quick project done for the Winter Lights Festival just to kind of test some of these like multi-user networking things. Maybe we should just try it real fast for anybody who hasn't tried it yet. And if anybody's watching on stream, you can try it too. But if you can scan this QR code, or maybe I'll do it now and then in here we can play later. But the whole idea is there's a projection here. In this case, there was a little QR code in the corner that you could scan, and you scan the QR code.
Can you move it up a little bit?
Oh, is it not visible? Got it. Cool. Let's try. The QR code specifically?
Yeah, there you go.
Okay, cool. This URL also works study.glitch.me, but we'll talk a little more about the internals of this, but the idea is, so that's me. So at the Winter Lights Festival, I built this over, hey, look at all that. Over the course of a few days, if you're interested in a deep dive on how this was created, I did stream kind of from start to finish making this. It's on my YouTube channel, and then there should be a playlist that is like work streams on the SETI YouTube channel that you can sort of just see how I did this. It was based on, years ago, I did a project for P5 that was kind of like an introductory video on how to do these simple particle systems. And then the idea here was to just add this. And so I think there's something to this. There's something to this in terms of like, again, everybody has this phone, it has all these sensors, it's a way to interact, it's a way to incorporate local and remote. This was not super ambitious in terms of the forms of input, but as I mentioned, this device has all kinds of forms of input. Accelerometer, gyroscope, compass, ambient light sensor, all kinds of ways that you could project something and then let humans kind of interact with their phones. The sky's kind of the limit in terms of what your creativity is given like what the device is. So just for some quick examples of this, you know, it's not as common now actually, but there's a microphone on the bottom of this phone, obviously, and it's there for talking. So you can imagine something like, oh, maybe I don't want my users to touch the phone. Maybe I just want them to talk into the end of the phone and have something reactive. Or maybe I want them to blow on their phone, and then I detect that they're blowing, and then I blow all the particles away or something like that. So I think there's lots of pieces here there's interesting possibilities, I think. And the places that again, in the work that David and I do, especially at really large architectural scales, this sort of communication can be really useful. If you're imagining, we did a project, again, we're a bit behind the documentation, but hopefully we'll have it up in a few weeks, but we did a project for Coach that was like a large scale many-story building projection in China, and there was kind of a question on like, well, how do you let people interact with a building? Like, it's just too big, they're like on the other side of some water, and we went back and forth a lot on different ways, and I think in the end it honestly ended up to be a bit more autopilot, because again, what they wanted was the slick production video, but something we vetted quite a bit was, okay, if you're on one side of a river, and there's an entire building over there, and you're gonna interact with it, like computer vision, probably not, physical computing, probably not, but everybody standing there had a phone. And so for very large scale architectural interactions, we've been exploring this as a way to do that. And so I thought I would spend a short time just kind of walking through some of the pieces of this. And then I do kind of want to open it up, especially for anybody who's in here. Maybe we'll get a little more hands-on and like play with what has increasingly become my shortcut for interactivity into interactive projections, because as I had mentioned, my favorite thing to do is the hybrid physical digital, where you have some physical piece to it. And again, once again, just to call out, a more exhaustive look at this is on the SETI YouTube channel if you want to see how it's built. I would not call this I'd call it maybe intermediate in terms of code. It's not how I would build something professionally, because it was kind of built to be a little simpler for P5, but we can look at the code and just talk a little bit about the pieces, because I think the main thing I just want to express here is that it is not just to do a small scale version of this, like, you know, if you want to do something here at SETI for winter lights or something like that, the ask at that scale, it's not enormously complicated. And, you know, as I mentioned, when you look at those team lab projects and you're talking millions of dollars with many very specialized professionals, this doesn't need to be in that realm. And a lot of the code that actually does the work is kind of cut and pastable code. Like, it's, even if you don't totally get it, it's pretty constrained. So just to show you, this is the entire server. Just this amount of code is all of the server code that lets the networking happen. And so and because Glitch is so cool, we've been using Glitch here, probably some of you have seen it in some workshops. Glitch lets you run the back-end code, the server code, and the front-end code. So if you're interested in doing interactive web stuff, I use Glitch, even if I'm going to do something that will eventually become like very heavy, very complicated, like, you know, professional level interactive experience that's going to get delivered to a client. I very often start with Glitch for prototyping, just because it's so easy to open up one window and be able to write the server, which this is a Node.js based WebSocket server. One thing I would just call out immediately, if you have any interest in simple ways to get things to talk together, I am a big fan of WebSockets, because at some level, just because of the world we live in, everything has a web browser, like to an absurd degree. There's just web browsers in so many devices, but obviously everybody's got a web browser on their phone. Every desktop computer, laptop computer, many kinds of embedded systems, there will be a web browser. And in many cases, for some of these sort of microcontrollers that are designed to be sort of quote unquote Internet of Things devices, very often as part of that realm of Internet of Things, there's a web layer to that. Like, even so often when we say internet, people are really talking about the web, and so it's very often to have very common to have an HTTP client, and then also very common to have a WebSocket client. And so we won't go deeply into that today. I believe I do talk about it at least a little bit at length in the videos for this, but I guess I just want to show you this file is 62 lines, right? Like, some of the projects I work on have tens of thousands of lines of code. This is 62 lines, and this is the entire server. There's not another file, really. Like, everything is in here. And I will also say a fair amount of this is just kind of like convenience or like robustness that isn't even necessary. Like, so this stuff that's like call idle clients, that's just me just saying like, okay, if somebody connects and it seems like they close their browser or they're gone or something, maybe I'll kick them off, or those kinds of things. So the piece that's actually doing the work is really just here, because it means that a message came in right here. It means the server got a message from one of the people's phones, and then I just go through and say, okay, everybody else gets that message too. And we don't have to go deeply into this. The main thing I want to express is really, again, 62 lines of code. Even if you're kind of a beginner and you're not exactly understanding what the code does, it's hopefully a thing that you could kind of like cut and paste and play with a little bit, just to get that, if you're interested in that. There's also lots of tutorials for WebSockets, because it is such a common way for, you know, web browser-based interaction to work. And so this is up on Glitch. It is linked in that document. Anybody's welcome to use this. I use this, you know, David and I all the time do networked things. David, who was here last week. very often we start here, just with this very simple WebSocket server that's just like anything that comes in goes to everybody. It's the dumbest server. You'd never use it in production. There's no security, anything like that. But just to start playing, it really is quite simple. And then I don't know, that we actually haven't done a ton of web discussion this time. We've done some P5, but in case the distinction is not clear, most of the time with web-based interactions, whether they're just simple, like load a web page, or whether they're more interactive, there's the server side, which usually just means somewhere there's a computer or something pretending to be a computer, and there's the client side, and that's your phone or your computer or whatever. And so this is the code that runs on the server, which in this case it's like running on some computer that Glitch owns, or running on some little virtual container that pretends to be a computer. Then there's the client side. So the client side is what you actually see. And just to show you that this page that you get to with the purple background that you can actually draw on to do the drawing is also barely any code at all. Like there's almost, the HTML file has almost nothing in it. This is just a little bit of styling to basically say, oh, the background should be purple. There's not that much to that. The actual logic code is in these two files. And again, we won't walk deeply through it, but I just want to show you the client networking side, the side that lets your phone send the information to the server and end up on everybody else's phone. Again, only 56 lines of code. And just to qualify it one more time, this is not something I'd use in production, but it's not too far. It's not too far from what I would use in production because it does have some robustness, like, oh, if the phone gets disconnected, we should probably reconnect, stuff like that. But so much of this code just is a two-way street. And so down here you can see this is the whole part of I want to send information out. And you can see it's just a function called send. It's a way to say I want to send information out to the world. And then the receive is a little more complicated, but not terribly. Like this is basically like I got a message in and then I do some work with it. And so just want to show you that's not a crazy amount of work. The sketch part, which is the processing part that so it kind of looks to see, if you look when you put here, there's a little kind of white circle that shows you where your finger is. That's in this file. Again, we won't go super deeply into it because it's on a stream. But again, under 100 lines of code, quite simple. And then the place that it gets more complicated, only because I made it complicated, not because it really has to be, is in this case, we also have the canvas part, which is the part that's on the screen. And maybe it bears stating, for these kinds of interactions, I usually break them into 3 categories. One of them is one-to-many. So that would be like the one that we looked at where there was all of the people in the audience with their VR headsets on. So in that case, we kind of had one point of truth. There was basically one computer running. Did I leave that one out? Yeah, so with this one, there was basically one computer running, and then everybody in the audience had their phone strapped to their face and was seeing this experience. So I would call that a one-to-many experience. That would also be, we've done things where there was that video doesn't want to load now. We've done something where we had an artist on stage, for example, drawing something in VR, and that was going to everybody's headset. That's also one-to-many. Sometimes you will do a many-to-one. I would call this a many-to-one, meaning there's one canvas. So if you imagine, this could be people standing in a room in an art gallery, or it could be an entire audience of 100,000 people at a show, at a concert, with a projection on screen interacting with it. Either way, it's still many-to-one, right? There's one big screen that everybody's looking at. In this case, it's our little cityscape. So the way this is designed, and this would, honestly, this one, because of the way I built it, would probably catch on fire if you tried maybe more than 30 people. But if built robustly, you could have any number of people in an audience. So I would call this a many-to-one experience. And then another one that is a bit less common, but we've also done it, and we won't really talk about it much today, is more like many-to-many. Meaning, not only does everybody see their work appear on the screen, but everybody gets everybody's work. And I have never found that to be very useful for in-person events. I have found for in-person, the one-to-many or many-to-one to make a bit more sense. If everybody's at their house then many to many makes sense. But kind of implicitly, if there is a big projection in a room, it's already the one. And so I don't find that as useful. But I just want to point that out because you can use that skeleton WebSocket code I just showed to do it either way. And then just to very briefly, again, go into this. The code for this part is a bit more complicated, but it's only complicated just because I'm being fancy with how I'm drawing the particles. But even then, it's just a few hundred lines of code. So for those of you that took a couple processing workshops, or like I think Yuri's workshop was in processing, this is very achievable, the thing that I do to draw up there if you watch that video. But the master, for anyone interested in anything related to processing or pre-5, is Dan Schiffman. And not only is he the master and one of the core members of or in my mind, maybe this isn't true, maybe I should be careful saying it, but he's a pretty core person in the realm of processing and the processing foundation. But he has done just tremendous work on making videos, usually targeted at kids, but for learning how to do these things, especially in a web browser, especially with P5. And so for anybody in this room or anybody watching who's like, I don't know. I don't know if I could learn programming, or I don't know. Dan Schiffman to me is the place to start. And he very frequently uses P5 now, which is very nice because he can just be in a web browser with the P5 editor and you can follow right along with the video, with everything he's doing. And the thing that I think is really incredible about his videos is he covers so much ground of so many different kinds of art or computation, certain kinds of algorithms. Here's an algorithmic botany video. So for anybody who's looking at these things and you're thinking well, I mean, I'm interested in interactive projections, but I don't know how to make digital content or whatever. This is, if you want to do it through code, I think this is a way to go for sure. For anybody who caught David's workshops last week, which are also on the stream, those rules that he was showing, all the artwork that he showed with sprites and shaders, all of that work can I think you looked at it in VR, right? You set up that scene and then he made the scene with VR where you could see the little fake SETI lab. That also all works in projection. So everything David showed last week for Unity also works plugged into a projector and projected on the wall. So you have a lot of content, and then again, Justin on Saturday did Touch Designer. So just to point out, there's no limitation kind of to the tools that you use. And actually, maybe that's a place here, and then we'll open it up a little more. A few final thoughts on this. One of them, and this is what I was just saying, the tools and techniques for creating digital screen-based content still apply. And so I really want to point that out because I think there is some software that is, in my mind, Touch Designer is kind of purpose-built for this, and there's other things people do with Touch Designer, but it is very commonly used. I especially see it with large-scale commercial production, kind of if a big architecture firm or something wants a big interactive element in a lobby or something like that, or for shows, events, Touch Designer is very common in that realm. And if that's your comfort level, and again, you should check out Justin's video, it should be on the SETI YouTube channel. If that's how you like to work, connecting the dots, connecting nodes, you can totally do that. If you enjoyed David's workshops, being in Unity and being able to fly around with the 3D camera and put that content together, you can totally use that. If you're more comfortable just with writing code, you can use P5 or open frameworks or any number of things. So I think one thing that's important to remember is it is pretty, as far as the generation of the content, pretty tech agnostic. And then I do want to point out again, I think there's many interaction patterns that still apply, but to me, the multi-user is pretty important. And I've definitely seen large-scale projections. This is especially a problem with Connect, basically. I don't see it as often, but say 8 years ago, it would still be common to go to a museum or somewhere like that, and there'd be some Connect-based installation that really only worked with one person. And so it just ends up being this thing where everybody's kind of standing in line or just waiting around on the fringes, almost all the way back to that first point of view artwork like that where only one person can use it. So whenever I do anything like this, I want to engage as many people as possible. And that's a big topic, and we'll talk a little bit about this, I think, with the musical murals on Thursday. But it's actually a pretty big challenge to design for flexibility in the size of groups. And that's something I've definitely found working with the Children's Museum so often, Children's Museum of Pittsburgh, is you want it to be fun if it's 1 or 2 little kids. You want it to be fun if it's a family with their children. You want it to be fun if it's a big group of school children. And interactive projections in particular, it can be hard to cover all those bases. And so, not that you always have to be all things to all people, it just sometimes isn't possible, but it is something that I think is important to think about, especially in like the context of what the space is and how it will be presented to the world, and whether you expect, will there be 8 people in front of this or will there be 80? And if so, I think the concept, that should really inform your thinking about kind of the interactivity part of that content. As you saw very often, for example, with those early Design.io pieces, they really built it so like, okay, we have a computer vision system that's kind of looking at the whole room, and so there can be kids all over doing different things. Whereas with TextRain is more constrained, but one of the things that's so fun about TextRain is it's just a video feed, and so you actually, I've seen 1 kid in front of it just playing with the letters falling down, and I've seen 20 kids in front of it just making a crazy, chaotic mess with letters flying everywhere. And so I think that's just something to think about. But I guess my personal recommendation would be to say, like, it's almost never fun to have a giant, large-scale thing that is really inviting and visually interesting, and then only let 1 person play with it. Maybe the one exception to that is if the activity is fundamentally a little bit of a performance. And so, of course, there's always exceptions. And I will say, David with Cosmic Sugar, for those of you that have tried Cosmic Sugar, he has done some situations where there might be someone in the headset with a large projection behind, where that person's in VR and they're doing their thing, but the thing that is really for the audience is the thing that's for the audience is like the large scale sort of performance that emerges from it. So I'm not going to say it never works. Sometimes it can be totally fine. Sometimes it actually is sort of fun to have a room full of people, and then maybe over here you give someone the controls to control everything. So definitely not a rule, but maybe a good guideline. And then this is just fundamentally true, and it always kind of surprises me how much people love mirrors. Like, it really is, it's something, again, I keep talking about the Children's Museum, but that is most of my interactivity that I've really liked has not been with these corporate clients, it has been with kids, because kids are less self-conscious about using their bodies and moving around and playing them, whereas if you're at, the corporate event, people are a little more hesitant maybe until they've had a few drinks. But just at the Children's Museum, a week or 2 ago, I showed Danny Rosin's wooden mirror, where it had the wooden mirror that you could respond to. Kids adore that. TextRain, even now, even when you look at TextRain and it feels a little rudimentary in terms of the technology, kids love it, and they play with it every day. And the biggest challenge, actually, for the museum with TextRain is supporting it and keeping it running, because it's like 20-year-old software on 20-year-old computers. That's not really, I don't think you could just run that software on a modern Windows machine. You have to have kind of 20-year-old equipment for it to run properly, which is interesting. But very frequently in the exhibits that we work on at the Children's Museum, there just will be mirrors, just actual physical mirrors. And sometimes we'll add a little interactivity in it where you can maybe there'll be a floor sensor that you step on, and then some lights come on around the mirrors, but it's just something to point out. And so for those of you that did take Catch Yuri's workshop, the idea of taking an image of a person and then doing something sort of artful with it is really incredible, and people really like that. And so that can either be with computer vision, using some of these complex computer vision things, for example, to say like, okay, I'm going to track your hands, and I'm going to do some artwork with your hands. But it doesn't even have to be that. It can just be like you make a fun, weird mirror, or do some fun, wavy thing, and it's a low. I don't want to say like low-hanging fruit, like it's not meaningful, but it is I think if you're just starting out and you just want to play with it, mirrors like that really can be fun, especially the bigger they are. And then finally, I mentioned this with the large. That large-scale Atari controller, but one of the biggest challenges with these kinds of things is the robustness and reliability. And that's just every piece of it. And because like I mentioned, when we talked about that treachery of Sanctuary project, how it's like, oh my gosh, it's Connect, and it's talking to open frameworks, and it's talking to Unity, and there's a computer here, and it's plugged into the projector. Even with that Hello SETI, which is so simple, it's like, well, okay, like we can't plug in to the internet, so when we're down the hall, we have to get that on Wi-Fi, and then people, oh no, if they like connect to the PSU Wi-Fi and it doesn't connect, there's just always technical issues with it. And so I think a thing to keep in mind with that, one thing, if it's just a show that's up for a day or two and you're going to be standing there to troubleshoot, that's one thing, especially if there's only like 8 or 10 people at a time. If you're starting to do like events or conferences where there's like 10,000 people, it can be a real challenge to have the robustness there. And actually, I mentioned that project we did for Forbes in Boston, and I mentioned that it kind of broke. One of the things that was in our contract was like, okay, if it breaks, we have to have a plan B. And so we did have a problem where the internet provider that they hired lost the connection. We lost our connection, which we were very clear from them. It's like, we require an internet connection to do this. If you lose an internet connection, our thing will not work. And they said like, well, what can you do? And so I basically had a fake, sorry I don't have more documentation for this, but it's not my favorite project. So, but the general idea was, there was an artist performing on stage in VR, and then everybody in their headset saw that artwork. And my plan B was, if the headset detected that it lost the internet connection, it would just go into like a pre-recorded version of it. So actually no one in the audience even knew. So no one in the audience knew that it broke, nobody knew, but it is a thing that you have to think about, especially with the AV equipment, especially if it's a physical thing that kids are gonna touch or people are gonna play with. And again, if we're thinking for the SETI show or Winter Lights or things like that, it's just a day or two, and if it breaks, and you can fix it and so on. But if you're interested in sort of pursuing this at a larger scale, especially at a scale of like permanent installations where it's expected that this runs every day, I can tell you, every single day at the Children's Museum, there's technicians that go around the hour before it opens and fix all the stuff the kids broke yesterday. And it's just ongoing. And so that's something to keep in mind in this realm. The end of the spectrum that is maybe the least that is if you can have a computer, it's all wired up and you don't touch it and it's on its own timer to turn on and off without the physical aspects. Like text strain, for example, is usually okay until lightning strikes and breaks the 20-year-old computer, and then you're in trouble. But it's a challenge with all forms of installations. That's just a thing to keep in mind. So I talked a whole lot. I want to move a little bit into hands-on stuff, and I want to open up for questions here. So maybe we'll stop the stream in a second. I do want to show one thing, though, one final thing, and then we'll close out the stream. I've been mentioning this idea of like, okay, my personal preference is the hybrid physical digital. Sometimes the hard part of that is getting the hardware to talk to the software. And this is kind of what we're going to play with today. We're going to look at P5, we're going to look at that circuit playground make code that we've played with in recent weeks, and we're going to look at glitch, and we're just going to kind of look at what it takes to have some very simple kinds of input. And so for those of you at home, when we stop, this is kind of the realm we're going to be in. And the core idea is that when you have a device like this, like these little microcontrollers, that one of the things that this device can do, certain Arduinos can do, the Teensy can do, that I think is like, if you're interested in the physical computing part of it, that sometimes is such a shortcut, is that these can actually emulate other kinds of USB devices. And so something I use fairly frequently, and we're going to do this on Thursday, so if you want a hands-on, like a deeper hands-on, we'll do this on Thursday to build our musical murals, is you can tell this device to pretend to be a keyboard, or to pretend to be a mouse, or to pretend to be a joystick. And so the big advantage of that is all that software that we've been talking about, Touch Designer, Unity, P5, getting a keyboard press in that, or a button press in that, like a mouse click, is dead simple. Like they're just made to do that. Versus the more traditional way to use these is that you would use what's called serial communication, and you'd be kind of sending data over, and it's just a big topic, and it can be a little daunting if you're just starting out. And just to show you a project, and we'll probably close the stream out after this, one of the projects that I did, and also maybe this will be interesting to see like kind of my start to finish on a project. It'd be nice, my prototyping would be a little, there's gonna be some jumps here. But I think I maybe talked a little bit about this particular musical mural a few weeks ago with sensors. But I just want to show you my process a little bit of me sort of like experimenting and saying like, so I have this projection here. This was an early version of the art. This was for a traveling exhibit for Rube Goldberg. So for those of you that are familiar with the artist Rube Goldberg, who's interesting, his legacy has really evolved. So traditionally, Rube Goldberg was a cartoonist. And his artwork was really focused on, let's just find it, Rube Goldberg, on like really absurd contraptions for doing very simple things. So this is kind of one of his canonical pieces, if we can actually find a reasonably sized image of it. To take the simplest task you could imagine, like wiping your mouth with a napkin, then he would draw this totally fanciful contraption on how can we do this? Like, what's the most absurd way you could do this? And so in this one, I think you like lift your soup up, and that pulls this, and it throws up a cracker, and then the bird moves over, and you know, you've definitely heard of this or encountered this. So his artwork is sort of like early mid 20th century, I think was kind of his main era. Let's see. Anyway, something really fascinating about him as an artist. So yeah, 1928. So really like early part of the previous century. One of the things that's so interesting about him is, again, he was an artist. He did these cartoons. They were deliberately ridiculous, but his name slipped into like common language because his comics were so common to say like, oh, it's like a Rube Goldberg machine, just to mean anything that's complicated. And then there was this crazy evolution, especially in the latter half of the 20th century, and certainly in the last few decades, of people kind of looking at that and being like, well, what if we really made those? And so it's become more and more common for people, especially students, physics students, to kind of do these very deliberate, like, oh yeah, how complicated can we get, right? Like how silly can we get? How ridiculous can we get? And sometimes like this sort of thing is very common, like a marble run of let's just release this marble and have it go. Or some people actually try to sort of make sculptures that are evocative of that. If anybody remembers, when I was growing up, there was a board game called Mousetrap, where the board game was really inspired by that. And I don't know if it's around anymore, but the whole idea of the board game was, the board game itself was a little Rube Goldberg machine. And if the wrong thing happened, it would trigger all these things, and this little cascade of events would happen. And at the end, I think your mouse would get trapped. So the idea was to make a mousetrap that was just so like overly absurdly complicated and silly. So anyway, the Rube Goldberg estate, in partnership with the Children's Museum of Pittsburgh, wanted to make a traveling exhibit that would travel around and be inspired by his work and not only showcase the cartoonist legacy of his work, of like the funny, absurd versions, but also kind of showcase what it has evolved into in terms of these like physical, interesting machines. And so, let's see, I think it's World of Hilarious Invention. So I was part of the development of this project, and you can kind of see that one of the things the museum endeavored to do was to sort of like try to make some of his machines. And they actually hired an artist, and it unfortunately didn't work out for the traveling exhibit because, like, you know, the nature of these devices is that they're absurd. And so there was at least a couple of artists that were hired to actually try to make some of the machines from his cartoons, which was never his intention. They were supposed to be absurd. But, so we had some sort of physical interactive sculptures that were inspired by his work, and I will say they were very fun, but they broke all the time and they just couldn't travel. We also had a realm of this kind of world, which was super cool, like especially some of the engineers at the museum built very functional Rube Goldberg machines that had still some of the fun and whimsy, but they actually worked, and the kids could set them up and they would kind of play through. My contribution was an interactive projection, and part of the goal, again, it was that challenge of like, okay, we have all these physical activities, some of them require gross motor skills, things like that, we want something that has accessibility. We want something that maybe has not only an audio component, but a visual component if you're visually impaired. Just to try, it's a goal always with the Children's Museum is to within one exhibit, have something for everyone. For every age of kid, for every kid that maybe just has a different set of abilities to be able to interact. And so the thing I was really interested in, one, is the musical part, and we'll talk more about musical murals later this week, because it's a universal thing that I'm very interested in, but it is also it's a way to like invite in people, maybe that are visually impaired or for whatever reason have difficulty with the visual aspect of it, so they can still enjoy the piece. I wanted it, again, because it's my favorite thing to do, to have kind of the hybrid physical digital, where the kiddos here had real physical ropes that they could pull. And then the idea is that you kind of see that rope continue into the screen. And we'll look at some of my test photos so you can see that a little better. And then I just created, and I worked with another illustrator to kind of flesh out the colors and match the rest of the exhibits, to have this like silly little Rube Goldberg interaction that would play music but have this hybrid physical part. So, again, like I mentioned earlier, often the most challenging part is like, how do you get the thing you make to talk to the software? And so I just wanted to run through a little bit some of these photos so you can kind of see what my process was on this particular installation, and show how the ultimate place I arrived was so dead simple in terms of the computer input part, and how actually it really tied well into the way I was thinking of and building the rest of it. And so, I showed, that was my idea. I had these early drawings of like, you go up and you pull a rope and a thing happens, and usually when I work with them, I will have a big range of ideas and we'll kind of pare it down. But the thing I knew I wanted you to be able to pull a rope and for a thing to happen. And so I started with these really rudimentary prototypes. So this is just me in the basement of the Children's Museum. What I usually do is they just have like huge parts bins and things from all of like, decades and decades of projects, and I just try to dig things out and put them together. And so the dead simple place that I started, and then this was supposed to just be the starting point, but then I decided like, I think this is the way I want to do this. As I mentioned, some of these devices can pretend to be a keyboard or pretend to be a mouse, and the computer doesn't know the difference. And so I know this is a bit of a jumble, but it really could not be more simple. So this is a microcontroller. This is an Arduino Leonardo, but it's not dissimilar from this. And all it is this black device right here. It's called a micro switch, and it's just like the most simple kind of switch. And it's probably in your dryer at home or your microwave. Like, it is a very common industrial switch that is just like ubiquitous across so many kinds of like hardware appliances. There's probably one in your car. Like, they're just so common. They're extremely robust. And all they are is just like, it's just a switch. It's just open, close, very, very simple. And my grand scheme for my prototype was like, okay, I found some springs and I found some bolts and things like that. So all that happens is when you pull this rope, this little spring compresses and it pushes this little arm, which is the way you push the button, basically. And you can see I have a little bit of wiring going into the Arduino, but the part of this that made my life so much easier is on the Unity side of things. There's another shot of that switch that maybe makes it a little more clear. Of just this coming down, and it just pushes this button. The thing that made life so much easier is on the art side of this, on the projection side, which again, you could make in processing or Unity or Touch Designer or whatever. I didn't have to have special logic to talk to the hardware, because all that happened is if you pulled that rope on the far left, it just pretended to press a key on the keyboard. And when you let go of it, it pretended to press another key. And as far as the computer knew, I think this computer actually was maybe my laptop or a Mac Mini. But on the computer side of things, again, Unity has it, Touch Designer has it, processing has it. Just a way to say, like, did someone press a button is like one of the easiest things that software can do. And so I was able to take that. And so this is my first prototype. It's very small. I think another reason I want to show this is to show you projects never start full scale. They always start small. And actually, this is even a little later in the process because, of course, to begin with, I'm just in the basement doing this stuff on a bench top. Then I make it a little bigger, and then we get the kids to play with it. And it's like, this is the first time that you see, like, okay, is this going to be fun or not? This, I think, actually was even the second prototype, because I think I did one before this where it was on a screen, and it was no good because kids think you can touch screens. And so the kids just ran up and touched the screen. I don't exactly know what it is about kids' psychology that makes them think that, okay, a projection I don't have to touch, but a screen, if it's a screen, maybe it's just raised on iPads and phones, hands immediately go on. Not as much of a problem here, but also it probably helped that there are a bunch of fun ropes to play with. And so this is where I started. Went through a few versions. You can see I'm adding color. I'm working on the artwork. The artwork is kind of evolving, doing some of these steps. This is now a big step later, after doing some engineering work and working with fabricators and figuring out like, okay, if I have 4, not just kids, but 4 parents, 4 of the biggest dads I can imagine are going to grab this rope and they just hang from it, this system needs to be able to support it. And that is where I absolutely look to the museum to do that kind of engineering calculation and make sure, and it was substantial. Like the end calculation was like, okay, we need like a huge steel beam at the top just to make sure that this will never put anyone in danger and be really robust, really stable. So it was a pretty burly steel frame. It's a little hard to see on the projector, sorry, but maybe that's a little better. You can see kind of the footprint of it because it's built to travel. And so this was built to go on the road. This is before I installed the ropes that went down into the screen, but you can see I have the physical ropes. And I can maybe hear it a little bit. Not really enough. But you can kind of see the idea. Is you pull these physical ropes, you see when I pull the physical rope, there's an immediate response on the screen of something happening. And then not only does the art play out, but then, once you have multiple kids and there's multiple kids like pulling and playing on it, like we saw in that earlier slide, maybe some of these photos show it a little better. It was quite big and it was quite heavy, but it worked out well. And it was a good mix, I think, to have this sort of physical digital projection-based thing. It was easily accessible to kind of roll in a wheelchair, have that accessibility. Again, it had audio accessibility. And for like really little kids, really, really little ones that could barely even stand up, could still kind of like lean on the rope and pull it. And so that was a goal with this, to kind of balance out some of those other installations that, as you could see, some of them you couldn't even get up close to. Like this one, you had to kind of be behind glass, which is sort of my least favorite kind of children's museum experience. Like it was necessary for this because it was so chaotic, but I always want kids to be able to like get up in something. And of course, kids always want to they want to touch things and play with balls. So you can see here, individual kiddos. And it was interesting to see that challenge of I definitely saw sometimes there would just be one kid and that one visitor would just run along and pull them. You saw families, there were groups of kids, and if you kind of pull them in different ways, you can sort of build the music. But the main thing I want to kind of stress on this one is just in the end, the simplest solution was actually the solution I went with for the hardware. And that is absolutely something that is available to everyone in this room. And I think that's what we're going to play with a little bit for the rest of the day. Before we stop this stream, does anyone have any questions that might be beneficial for Streamland?
Going back to computer vision, with the kind of more brute force pixel analysis versus
the machine learning of today.
Is there a significant difference in processor intensity between those two?
There definitely can be, and I think sometimes it's not where you would think it would be. So in some cases, the brute force stuff, which is very adequate for certain kinds of things. In fact, I think one of the classic examples of that as far as a commercial delivered project, even though I don't think it was the best commercial delivered project, was the PlayStation Move. If you remember the PlayStation Move, it was basically a glowing ping pong ball on the end of a wand. And when PlayStation released their VR headset, this is what they used for input. One of the reasons they did that is the computational stress of this particular thing. They made this device sort of well before we were really thinking of ML for this kind of interaction. There's two kind of cool things you can do. In fact, I'll say there's 3 things you can do here that are cool, just maybe not super robust. But you could do this. Like you could write this in processing and do this, and I've seen people do it. You would go through, you'd loop through all the pixels. So part of the processing question is like, well, how high resolution is the camera? At this era, if it was maybe like 720p or lower, that's one thing. Once you're in 4K, you're dealing with millions and millions and millions more pixels. And so that's one question of where the computational stress is just the number of pixels. Two is how quickly you think you need to process them. Your normal intuition might be that, oh, I should process them as fast as I get a frame. And so this camera was probably something like 30 frames per second, that first PlayStation 4 camera. PlayStation 3, even PlayStation I. But you don't have to necessarily. And it's not uncommon for, if computer vision even now is a bit computationally intense, to kind of do it in parallel. And so you'd be showing the video every frame because you want it to be a good experience for someone. But maybe you're actually like only doing the processing every few frames. So that is another way that you can alleviate a little bit of the processing. But the three things that this did that is very cool in terms of that, brute force is maybe not exactly the right term, it's what I would call it, computer vision, is one, it made a very bright thing on the screen. And it's very easy, especially if you watch those Schiffman videos, you're going to loop through and you can get the brightness of a pixel in processing, for example. And so it was not hard to just say like, okay, I'm looping through these pixels. There's a bunch of really bright ones over here. So I feel pretty confident that that's where it is. The second thing that it could do that was cool is it would color code multiple players or the left and right hand. So not only can you say, how bright is the pixel? You can say, find the really bright pixels, and then what color are they? And then it could know if it's your left hand or your right hand, or one person or the other. Now, that's another thing about the computational stress of it, though, is now we're looking for two things. We're checking two things. We're trying to like think about where two things are. So that kind of computational pressure often, I would say, generally increases linearly with more people, but not always. Sometimes there's like some base sort of like cost of doing business, just like some foundational work, and then like the slope is there. With this kind of work, I would normally think of it being exponentially harder, but there'll be a point where it's like, okay, if you're trying to track 6 of these, depending on your video resolution, depending on the computer, it might get too slow to be useful. And then the third thing that this could do that in theory is quite cool, in practice I found never to work very well, is if you think about it, if you know your camera very well, in this case it's a specific Sony camera, you know the field of view of that camera, you know the physical dimensions of that camera. If I show a circle that's bright, and I found it, you can make assumptions about how far away it is because you know the camera, right? You know the field of view, and so you can say, like, okay, I know the field of view. I know that this ping pong ball is exactly whatever, 30 centimeters wide diameter. Not 30 centimeters, like 30 millimeters wide. And because of that, I can assume that it is 2 meters away or something like that. So it was cool, and it was a lot to happen, but those are kind of, now that's 3 things we're checking, and so now there's more computational pressure, there's more there. The thing, though, is that in this case, that a lot of the computational weight of it is at runtime, like it's happening at runtime. Once you get into ML models, things get a little different. One, because very often the training of that process, I mentioned sometimes it's like, okay, maybe instead of this, we set up some sort of setup and we have 10,000 pictures of different ping pong balls, and that's how we're going to do this. Very often, and it's getting better, but very often the training process can be hours or even days. Like there's some ML models that you just are like, okay, I'm going to set this up, I'll be back in a couple days. And so there's a lot of weight there, there's a ton of computation there, but it's offline, so it doesn't matter as much. Then the other thing in this realm specifically is there's been so much work, especially in recent years, for dedicated hardware to do this kind of processing, or hardware that is a bit more general purpose. So if you've heard about the many ways in which you can use your GPU as a bit more of a general purpose device. So you will very often now find that even if there's some incredibly heavy aspects of computer vision, that if you were thinking those as like single-threaded CPU problem you're trying to solve in real time as a video is going, would seem untenable. You can have this specialized hardware in your computer, potentially, or some, like that OakD camera I mentioned, where it has some hardware inside of it to do some ML, or the Microsoft approach with the Azure Connect is more like, send it to the cloud. And so the Azure Connect is very tied into their kind of cloud computing ecosystem. And then you get into the idea of like, well, then you have infinite compute. There's a lot of reasons that that's not exactly true. You have issues with the networking. Of course, they're going to charge you some amount based on what you're doing. But it gets a little more complicated because like, I would say, I guess the really short answer to that is that's a fairly easy thing to assess with the old school way because it's code that's running on your computer right now and you can tweak it if you need to. And it's not uncommon, I should say, it's actually quite common, especially in this era, to say like, okay, I have the really high-res video and that's what I'm going to show to the screen, but then in the background, I'm going to have like some super shrunk, like that's quite common really, or was at the time to say like, you're going to do your blob detection on a video that's only a tenth of the size. And so some of that stuff is a bit intuition based, and then now it's a bit more complicated because like who can say where the work is happening? Is it in the cloud? Is it in hardware or whatever? But that is a thing that many of these systems sort of purport to solve for you, but with a cost. Yeah. Cool. Any other questions about this kind of stuff? Cool. So maybe we will. I don't think there's anything else I wanted to share. I don't think so. I think the next thing I will say is like a lot of these things that I talked about today obviously are not just limited to projection. That was kind of what we're talking about. Some of these things will apply to other kinds of multi-user interactive things, physical murals, things like that. But I just wanted to talk about it there. And again, go check out these other videos. Justin's video on Touch Designer. You can check out the Mad Mapper videos. You can check out me talking about sensors more. So because a lot of the stuff that we've talked about so far in the institutes will filter into this. And yeah, just have some fun ideas and start to play, watch some Schiffman videos, whatever. And then I think that's probably it for the stream, unless, was there anything else on Dini? Yeah. Okay, cool.